Have you ever pondered why an apple falls straight down from a tree and not sideways or upwards? This seemingly simple observation led to a revolutionary understanding of the natural world, thanks to Sir Isaac Newton. Today, we delve into the fascinating world of Newton's laws of motion, the fundamental principles that govern the movement of every object in the universe, from the smallest particle to the largest galaxy. First, we'll explore Newton's first law of motion, also known as the law of inertia. Picture a soccer ball sitting on a field. It would remain at rest, not moving an inch unless a player kicks it. Similarly, once that ball is in motion, it won't stop or change its direction unless something else, like a goalkeeper's hands or the net, interferes. This is the essence of the law of inertia. An object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction, unless acted upon by an unbalanced force. Next, we turn our attention to Newton's second law of motion, or the law of acceleration. Imagine a small car and a large truck both moving at the same speed. If you were to apply the same force to stop both vehicles, the car would stop much quicker than the truck. Why is that? That's because the force required to change an object's motion is directly proportional to the mass of the object and the acceleration produced. This law gives us the famous equation, force equals mass times acceleration, often written as F equals ma. Finally, we come to Newton's third law of motion, or the law of action and reaction. It states that for every action there is an equal and opposite reaction. Think of a swimmer pushing off the wall of a pool. As she pushes the wall pushes back with an equal force, propelling her through the water. This law explains why we move forward when we push off the ground while walking or running. In essence, the laws of motion dictate how objects behave under various conditions. The first law, the law of inertia, tells us that objects resist changes in their state of motion. The second law, the law of acceleration, quantifies the amount of force needed to change an object's motion. And the third law, the law of action and reaction, explains that forces always come in pairs, with every action producing an equal and opposite reaction. Newton's laws of motion are fundamental to our understanding of the physical world. They explain everyday phenomena and govern everything from the tiniest particles to the vast expanses of the cosmos. They are integral to fields as diverse as engineering, sports science, and astrophysics. They remind us that we live in a universe of order, predictability, and extraordinary beauty. So, the next time you see an apple fall from a tree, remember the profound principles at work, the laws of motion, that make such a simple event possible. Think about how these laws govern not just the apple, but everything around us, including us. And remember, every object in the universe, no matter its size or speed, obeys these laws. They are the silent, unseen forces that shape our world and the cosmos beyond.